Mr. Harmless here, and we're still talking about geometric means when it comes to right triangles with an altitude. And we gave you before the geometric mean of the two numbers a and b. If I am trying to find the geometric mean of these two numbers, a and b, I could find the geometric mean by solving for this x. Okay, so with that in mind, we can figure this out here. This is the length of the leg of a triangle. So let's pick one, AB. The leg of a triangle, AB, is the geometric mean. Oh, I put it in the other spots, didn't I? It would be okay to do it this way, but I don't want to confuse you. AB. So the length of a leg, AB, right, because that's the leg of this bigger triangle, it's the geometric mean of two things, right? One thing is the hypotenuse, in this case AC, and then the segment of the hypotenuse next to that leg, right? Adjacent means next to that leg. So the segment of the hypotenuse that's next to it would be AD. Now this would work for either leg, because I could say, okay, well, what if I said BC? Because BC is also a leg of that original triangle. Leg is the geometric mean of the hypotenuse, still AC. And the leg that is next to the leg, or the segment of the hypotenuse next to that leg, in this case, DC. So this works with any right triangle that has an altitude, which means in a problem like this, we could solve for x, because x is a leg of this right triangle, and we have an altitude here, okay? So if I use this pattern that I just figured out, and the way that I always remembered this in my head when I was a kid, when I was in school, there wasn't an actual formula. I was just given this, but the way I memorized it in my head is I would say this in my mind. I'd say hypotenuse over leg equals leg over the segment adjacent. That's how I memorized that. Now this works if you keep in mind it's some of the leg of the original triangle, the hypotenuse, and this is the segment of the hypotenuse that's next to that leg, adjacent to that leg. So hypotenuse, leg, segment adjacent. So in this problem, the leg, in this case, of the big right triangle, the largest right triangle, is x. So I'm going to put x here and here. The hypotenuse is, well, the whole thing would be 26, right? That'd be the hypotenuse. That's this whole thing. And then the segment adjacent to this leg that I'm looking at is 24. So here we have this problem set up, and we would just cross multiply to solve. I'm going to grab my calculator. I know you can't see it, but 24 times, or 26, right? 26 times 24. And we'll stick that right there. So 24 times 26 this way is 624. X times x, x squared. And then you would take the square root of both sides. And if necessary, simplify. And so the square root of 624, I don't remember if that one comes out evenly or not, but let's try it here. Square root of 624. Yeah, that doesn't come out evenly. So the square root doesn't come out evenly, but you could simplify that. Square root of 624. You would simplify that down and into a simpler number. But we're not focusing on that right now. We're focusing on how you set up the problems. And if you need a video on how to simplify square roots, I can make a separate video just for that. Now let's take a look at this next one here. Once again, I have this leg is x. So I'm going to go x. So the x is going here and here, not because that's where the x always goes, right? I know that was here and it was here. I'm putting this here because the formula says that it's the leg that goes there. In this case, x is the leg. And then on the top, we're going to put the hypotenuse. In this case, it's 12, right? And then down here, we're going to put the segment of the hypotenuse adjacent to this leg. Well, that's right here. So I'm going to have to do this 12 minus the 7 to figure out what that is. And I believe that is 5. Okay. So we cross multiply to solve. X times x, x squared. 12 times 5, 60. Square root both sides, and we get x is the square root of 60. And once again, you could solve this, or I'm sorry, simplify this down to something a little bit easier. But now if we take all this stuff together that we've learned from this one and the previous one, there's more things that you can do. So I'm going to make a separate video because this involves not just the leg theorem, but it also involves the altitude theorem and solving for some missing parts in this triangle. In fact, you could probably also throw in the Pythagorean theorem into the mix as well. Okay. If you have any questions, let me know.